welcome back. Let's do question 8. In the diagram, O is the center of the circle. So we have to think about the center theorems here. Right, use the diagram above to prove the theorem which states that the angle subtended by a chord at the center of the circle is equal to twice the angle subtended by the same chord at the circumference. That is, we have to prove that angle TOP, this angle, is equal to 2 times angle TKP. So how do we do that? I'm going to show you 2 methods here. Let's start with the first one. And the first thing to remember is actually the construction. What should we construct? And then after that, we have to remember the theorems that we use. Like the first one, we have to construct a line that will pass O from K. This is the line here. Why are we doing that? We are going to create an exterior angle of a triangle. So you have to remember exterior angle of a triangle. Right? Remember that. Let's say we have a triangle like this. Right, this is an exterior angle of a triangle. And then this angle, let's call it C, and then is equal to A plus B. C is equal to A plus B. And then the other thing also, you have to remember the angles opposite equal sides, because KO and OT are equal, and also KO is equal to OP. So we have exterior angle of a triangle and also angles opposite equal sides. Let's name our angles. This is angle O1, angle O2, and then angle K1, angle K2. And then from this, we can say that angle O1 is equal to what? This is angle O1. It is equal to angle K1 plus angle T. Angle K1, which is this angle, plus angle T. What's the reason? Because it's an exterior angle of a triangle. We have this triangle here. Let me use a blue color. We have this triangle. So angle O1 is an exterior angle of this blue triangle. Alright? It is equal to angle K1 plus angle T. Exterior angle of triangle. But what can you say about angle K1 and angle T? Angle K1 is equal to angle T. Then what's the reason? Angles opposite equal sides. We can replace angle T with K1. So meaning that angle O1 is equal to angle K1 plus angle K1. So we can say therefore angle O1 is equal to angle K1 plus angle K1. We can say that because angle T is also angle K1. So we can say therefore is equal to 2 times angle K1. That's the first part. Meaning that this one is 2 times angle K1. And then we move on to triangle KOP. Similarly, we can say that angle O2 is equal to angle K2 plus angle P. Angle O2, this angle here, is an exterior angle of a triangle. But this angle and this angle are equal because they are angles opposite equal sides. KO is equal to OP. So we can say but angle K2 is equal to angle P. Right? These are angles opposite equal sides. Since angle P is equal to angle K2, so you can replace this angle P here with angle K2. So therefore, angle O2 is equal to 2 times angle K2. This angle is 2 times angle K2. Now let's look at this whole angle here. This whole angle TOP. The angle TOP. Angle TOP is equal to what? Angle TOP is equal to angle 2 times angle K1 plus 2 times angle K2. That is angle TOP. We can factor out 2 and remain with angle K1 plus angle K2. And then if we check, angle K1 plus angle K2 is actually angle TKP. This is angle TKP, angle K1 plus angle K2. So therefore, we have proved that angle TOP is equal to 2 times angle TKP. Right, the second method, we have to use angles in a triangle. The sum of interior angles of a triangle, we know that they add up to 180 degrees. Right? If you have a triangle, then A, B, C. A plus B plus C will give us 180 degrees. The other thing, you have to know that angles around the point add up to 360 degrees. So what we do here, we construct KO. Remember the construction. Every time you're proving a theorem, you start with construction. Now we've constructed two triangles. Triangle KOT, which is a blue triangle. Let's start with that. Let's name this angle K1, this one K2. So we can say that angle K1 is equal to angle T, right? Because KO and OT are equal, these are radii. So we can say angle K1 is equal to angle T, and then there is in angles opposite equal sides. These are angles opposite equal sides. So where there's T, we can put angle K1, isn't it? Because they are equal. What is angle KOT? What is angle KOT? Therefore, angle KOT is equal to what? This is K1. We say this is K1. This is also equal to K1 because these are angles opposite equal sides. So angle KOT is going to be 180 degrees minus 2 times K1. Why? Because interior angles of a triangle add up to 180 degrees. So we're looking at the blue triangle here. So it's going to be 180 degrees minus 2 times K1, angle K1. Angle sum in triangle KOT. This is triangle KOP. Triangle KOP, we can say that angle K2 is equal to angle P because KO and PO are equal. These are radii. So you can say angle K2 is equal to angle P, and then these are angles opposite equal sides. Where there's P, we can put K2. So this angle is just like K2 because they are equal. Therefore, angle KOP is equal to 180 degrees minus 2 times angle K2. Again, angle sum, and then in triangle KOP. Now we have angle KOT, we have angle KOP. Now we can find this angle because these three angles are angles around a point, right? So what can you say? We can say that angle TOP, therefore angle TOP is equal to 360 degrees, right? Minus angle KOP, and then also minus angle KOT, because these are angles around a point. We are separating these two angles around a point, right? So it's going to be 360 degrees, then minus 180 degrees minus 2 times angle K1, then plus 180 degrees minus 2 times angle K2, right? We found that this is KOT, this is KOP. You see that? And then now we can simplify inside the bracket there. Becomes 360 degrees minus 360 degrees minus 2 times angle K1 minus 2 times angle K2, right? And then if you remove this bracket, this is going to be 360 degrees minus 360 degrees, which is 0. Then negative times negative here becomes 2 times angle K1. Then negative times negative there becomes 2 times angle K2. Okay, and then now we can see that this angle TOP, this angle TOP is equal to 2 times angle K1 plus angle K2, like this. If we factor out 2, and then meaning that angle TOP is actually equal to 2 times angle TKP, because TKP is one which is angle K1 plus angle K2. So that's another way of doing it.